All right, welcome to my final project for the Duke Managing AI Projects final project. So to start off, my initial problem was that I want to solve for is predicting replenishment and labor needs in a distribution center for a retail organization. I think this problem is attractive because being able to predict the labor needs for a distribution center can impact the organization dramatically, monetarily and employee satisfaction wise. And I think machine learning can help solve this problem because of the massive amount of data that we have, the different approaches that we can take using machine learning models to solve this problem. And then people are going to care about this because saving money in a large organization is really important. So defining the problem, the target user for this is likely a distributed center ops manager. The problem statement is going to be determining the right level of labor needed to be staffed. This matters because being able to accurately predict our replenishment staffing will allow us to both reduce the number of labor hours during slow times, but also ramp up staffing during times that we expect high volume so that we can keep current employees happy. Right now, our current approach is a rudimentary heuristic model or method, not a model, to basically look at historical data and determine for this day last year, what did we need, that kind of thing. It leaves a pretty big gap because today and last year might be wildly different, and we can use this year's trends to help us back into a better date or a better number for today's date. Defining success, I think there's two things that we can define here. One is dollars spent on labor hours, whether it's probably a change in labor hours compared to last year. And then employee satisfaction, making sure that if we are changing labor hours and dollars, are our employees also being happy or are happier in that area. On output, an outcome metric here, like I said, probably average labor hours per person, along with total labor hours for the distribution center. Output metric is likely going to be some sort of mean squared error like metric, because the model is probably going to be regression based in some fashion. Relevant factors include sales data, stocking levels, seasonal trends, distribution center characteristics, what's the size of the distribution center, what's the volume that goes through that. All of these things I think can lead into how much effort and time is needed for employees to do the replenishment activities. So my solution would likely be to have a machine learning powered integration with a scheduling application. To go about this iteratively, I think putting together a mock-up with kind of our thoughts on what we could provide if we had if we were able to be successful, getting feedback on that to make sure that we're chasing the right business pieces, putting together a wireframe, continue to get more customer feedback, and then go with a heuristic approach. I know the current step is pretty much just a heuristic approach. I think we could improve on that, but also improve on that to get some trust, but then also make steps towards our final model development. So we'd iterate over building out the model and then integrate it when we can. System design, I think cloud processing, cloud-based is going to be the way to go. It's not very time sensitive. Our privacy isn't a big deal. I think we'd be able to have our own cloud instances. so that we can keep things private. Offline learning is and batch predictions are probably okay in this situation. Being able to schedule out those things are going to be fine. The data pieces aren't going to change too frequently, and then the predictions needed are going to be at a set interval. Say we schedule out 2 weeks, so every 2 weeks we are going through the process again, that kind of thing. Potential risks I see, data drift. With that offline model, I think there runs the risk of having the business change around us. So we'd have to monitor that to make sure that we're retraining at certain intervals. I think training service skew might impact us. We have a large amount of distribution centers, and those distribution centers all are pretty variable in design. So making sure that the different distributor centers are representative of our data is going to be important. All right, so thank you for watching.